Welcome to the Explainer. Today, we're diving into something super exciting and honestly, highly relevant right now. We're going to completely demystify how you can contribute to vLLM. Now, if you're not familiar, vLLM has exploded into this massive, cutting-edge open source project. It is literally changing the game for how large language models are served and utilized. But look, staring at an enterprise-scale repo from the outside, yeah, it can feel a bit like looking up at a sheer cliff face. So, our goal today is simple. We're handing you the ropes, the harnesses, and the exact handhold you need to go out there and make your very first contribution. All right, here's our roadmap for this explainer. We're going to look at the scope of vLLM, how you can actually contribute, and where to find your first task. Then, we'll wrap it all up with getting your environment set up and compiling the build.
Section 1. The scope of vLLM. It is, frankly, a staggering scale.
And what's wild is that these terms, they barely even scratch the surface of the index we found in the source material. We're talking about deep, highly complex AI topics living inside this repository. Things like speculative decoding, disaggregated serving, FPA quantization, fused mixture of experts, modular kernels, Nixel KV cache lease renewal. Phew, just reading those out loud is honestly enough to give even a seasoned dev a serious case of imposter syndrome, right? It absolutely establishes the immense prestige of the project, but, it also kind of creates this mental barrier to entry. You sit there and think, wait, if I don't have a PhD in machine learning, how on earth am I supposed to contribute to this?
Well, that brings us to Section 2, how you can contribute. And thankfully, it's a very welcoming reality. Just take a look at this quote right from their developer guide. I love this. It brilliantly captures the team's ethos. They explicitly say, "Our community is open to everyone and welcomes all kinds of contributions, no matter how small or large." Boom. That is a massive green light, guys. It just completely dismantles that intimidation factor we were just talking about. The maintainers know their code base is a behemoth, and they are actively rolling out the red carpet for you to come in and help. So what does a contribution actually look like in the real world? Honestly, it's a huge spectrum. Sure, yes, you can identify and report bugs or suggest and code up new features, but you can also improve the documentation or write a handy how-to guide. In fact, the docs specifically highlight that just answering community queries, offering pull request reviews, and helping other people out are highly, highly regarded ways to pitch in. And hey, if you're not quite ready to touch the repo itself, you can still contribute by raising awareness on social media, writing a blog post, or literally just dropping a star on their GitHub repo. Every single one of these actions genuinely moves the open source needle forward. Moving on to Section 3, finding your first task. Where exactly do you start?
It's literally the most common question when you're staring down a sprawling monolith of code. Unsure on where to start? It's totally normal. And the great thing is, the documentation anticipates this exact moment of hesitation. They've provided a dedicated job board section that's specifically designed to gently onboard new maintainers.
The big takeaway here is that you absolutely do not need to aimlessly doom scroll through thousands of open issues. The documentation gives you direct links to curated lists. You can click right into Good First Issues. These are handpicked for beginners. There's a whole board for selected onboarding tasks. Or if you've got a specific niche you're into, there are filtered lists for new model requests and models with multi-modal capabilities. These links are essentially hidden treasures. They take the guesswork completely out of the equation and point you exactly to where your help is needed the most right now. All right, Section 4, Environment Setup. Let's get your local machine prepped. The source documentation actually outlines a really clean, progressive scaffolding to get your local machine ready to go. Step 1, naturally, is to just clone the vLLM GitHub repository to your local drive. Easy enough. Step 2 introduces a specific tool recommendation for configuring your Python virtual environment. You'll want to install something called UV. And then Step 3 is just utilizing that tool to create your new Python environment so all your dependencies stay perfectly isolated. I actually want to pause on this UV thing for a second because it's a fantastic technical takeaway. The vLLM project specifically recommends using UV, which is a super fast Python environment manager. They even link straight out to the UV documentation for installation instructions. By adopting the tools that the core maintainers themselves recommend, you're ensuring your local dev process is as efficient as humanly possible, and you're perfectly aligning your workflow with the rest of the community. It's a real win-win. Okay, bringing us to Section 5, compiling and building. This is the final piece of the puzzle. At this stage, you're going to hit a bit of a fork in the road. The documentation splits the build instructions based on what you actually want to achieve. Are you going to be a Python-only developer? Or are you a Python and CUDA or C++ developer? If you're purely working in Python, the installation is a breeze, just a simple command to build and install the package. But if you're planning on digging into the lower-level hardware execution, you'll need to follow a more specific track.
If you are on that CUDA and C++ track, the source gives you a very careful, sequential process, so you don't end up trapped in dependency hell. So, step 1, you must install PyTorch first. Step 2, you then install the necessary build dependencies directly from the requirements/build/cuda.txt file. And step 3, and listen up because this is absolutely crucial to this workflow, you must skip installing Torch during that second step because, well, you already installed it in step 1. The documentation explicitly warns about this just to make sure your build compiles flawlessly on the very first try.
So we've gone from looking at the overwhelming scope of a massive AI project all the way down to the exact command line steps to build it right on your laptop. You know that contributions come in all shapes and sizes, and you know exactly where the community keeps its starter tasks. So I'm going to leave you with this. The door is wide open, the documentation is incredibly supportive, and the open source community is waiting for you. What will you build with vLLM today?